For this video, I'm going to show how the method that I use to calculate an 8-digit square root to 4 decimal places works. Now, from the previous video I created, I showed the method, and the three numbers that I wanted to save from that method are the three numbers that I'm calling x0, x1, and x2. This x2 is the square root to 4 decimal places. The reason why I save those numbers will be apparent for this, but if you need a reminder, this is the calculations that I went through before to show how to find the square root of an 8-digit number. First, I did a linear interpolation, which I will get into, and I didn't show you how to do it, but I did it here, and that creates our first guess. Then I divide that into here to get our second guess. Well, actually, this is part of our second guess. We add these two numbers together to get this number, and divide that by 2 to get our second guess, or first guess, if you will, which is 4501.45, which is x1. The 4473 is x0. Then you divide this into here, and you get 2250.6682. You divide this one by 2, you get this. Add those two together, and you get the answer, which is x2, which is what I saved up here. This is the method that I use to calculate square roots of an 8-digit number. Now, how does all this work? Well, the real magic sauce in this is how to figure out our first guess. We're doing that with a linear interpolation that proceeds like this. In order to find a square root, we need to have a first guess, which looks like this. We know we're in the range of 4,000 to 5,000 for our answer, so that's here and here. And we know that if you square 4,000, you get 16 million. And if you square 5,000, you get 25 million. And the parabola is going to look something like that. That's a little bit steep there, so I'm just going to go continue up. So how are we going to, and 202625 is somewhere, I would say, about right here. Somewhere in there is 20262541, which is about right there. And the number we're trying to find is this one right here. So how do we get started? Well, what I chose to do is to find the linear interpolation, and I'm going to use my pointer to help me here. Draw a line on from here to here, and please excuse the non-straightness of that line. Didn't do it very well even with a guide. But anyway, that's a straight line. Let's pretend that's a straight line. And what we're going to do is find the point on this line that intersects with this point, which is going to be here. Now we know that that number is going to be here for our first guess. And we also know it's going to be less than the answer because the line is always going to be to the left of this curve. So how do we find x0? Well, we need to find the slope of this line. So if we use the formula mx plus b, that's the formula for a line, and we don't really care about the b in order to find the slope, so we're going to ignore that. Then, in order to find the slope, y over x. So in this case, y is 25 million minus 16 million, or 9 million. And in this case, in all cases for us, it's going to be 1,000 for the difference in x. Now, a word about this. Why is 9,000? Is it always going to be 9,000? No. If our number here were larger than 25 million, then this number would be above here, and that curve would be continuing up. And the part we would be interested in would take this 25 million and put it down here, and then this will be a 5,000. That will be a 6,000, which would make this 36 million. 36 million minus 25 million is 11 million. However, all these numbers are interrelated. This 9 comes from this 4, which turns out to be our first digit of this answer that we found by taking the square root of that. This particular 9 comes from this, where you double that number and add 1. And it turns out if this was 27, 28, 29, and it was up here somewhere, and this were 25, and this were 36, that would be 11 million, which would be 5 times 2 plus 1. So in all cases, this slope, if we divide this out, is going to be, I'm going to call 4d. d times 2 plus 1 times 1,000. And that is going to be our slope of this line in all cases, no matter what the square root is that we're looking for. Which is why when you look back at the original division that we did, we divided by 9. We did 2 times 4 plus 1 and wrote it down here. That's why we did that. Now, how did we end up with a 40 here instead of a 20 or a 52 or a 42 or something like that? We added 20 to these first two digits and put it here. Why did we do that? Well, that's going to take some algebra. In order to do a linear interpolation, now that we know that the slope is 9,000, what that means is there are, for every one of these, when I go from 4,000 to 4,001, or 4,100 to 4,101, or any number in here, this goes up 9,000. So what we really want to know is how many 9,000s are in between here and here. So what we need to do is take this minus this, divided by the slope, which is 9,000, and then add back in the 4,000 that we're looking for. To do the algebra, I'm going to remove this chart, but I'm going to leave this. So I'm going to restate what I just said. What we need to do is take the difference between this number, we're going to call that n, our number is 20 million, subtract this number squared, which is going to be 1,000 squared d squared. If you square d, which is 4, you get 16. 1,000 squared is a million, so that is 16 million. And then divide that by the slope, which is 1,000 times 2d plus 1. And then we're going to add back in this 4,000, which is 1,000d. That is how we're going to figure out what to divide the 9 into to get our first guess. So the first thing that I want to do is divide out this 1,000. We're going to end up with, no, actually this is going to be x0. And I'll explain why we call it x0 in a minute. So if we divide this out, it's going to be n divided by 1,000 minus 1,000d squared over 2d plus 1. Now, in order to bring this up into this part of the equation, we need to multiply this by 2d plus 1 over 2d plus 1. So, plus 1,000 d, ooh, that's a bad d, d times 2d plus 1. If we multiply that out, we end up with n over 1,000 minus 1,000 d squared plus 2,000 d squared plus 1,000 d. Now, minus 1,000 plus 2,000 ends up plus 1,000, and we can get rid of that. Oh, and then we want to divide all this by 2d plus 1. So, factoring this stuff out again, what we're going to end up with is n over 1,000 plus 1,000d times d plus 1 over 2d plus 1. And that is what we use to calculate our first guess. Now, how does that work? Well, now we can erase this. Take n over 1,000, which in our case means ignore the last 3 digits. So, n over 1,000, ignoring the last 3 digits, is 20262 plus d times d plus 1. D is 4. D plus 1 is 5. So, plus 20, and then the 1,000 means just shift it over 3 decimal places. So that is why we end up doing 40262, which shows up here in our original method. That's why we do that. And then we divide it by 2d plus 1, which is 9. And then we get 4. Again, we're going to do 4. That's a 6. That's a 7. That's a 3. And then that's a 3. And there's our first guess. Equals x0. Ta-da! That is the linear interpolation of the parabola between 4,000 and 5,000, 16 million and 25 million that we're going to use to do the original method. Just because the algebra is a little bit complicated doesn't mean that the math has to be calculated. This 1,000 simply shifted the 20 over a little bit. It says basically take these 2 digits, multiply them to get this times that plus 1, shift it over, ignore 3 digits from this guy, and then divide by 2d plus 1. That's how we got x0. Now, so what? We have our first guess. What do we do with it? Well, what I haven't mentioned so far is that this method is based on something called the Babylonian method. It's a method of finding square roots that is thousands of years old. And how it works is it's an iterative function that says x1 equals 1/2 x0 plus n over x0. That's why we call this x0. In order to find x1 in this case, we're going to take 1/2 of 4473 plus the original number divided by 4473, which according to this is exactly what we did here. Now that we went through the step to do the linear interpolation, which was a very simple division, we then take x0 and divide it into the original number, and we get our first division. And then I go through the steps to do the long division to get that answer. Then we take x2 and we go 1/2 times x1 plus n over x1, which is what we did for the second division, which was this one. But we didn't exactly divide by x1. You notice this is 2x1 because we had to divide by 2 to get this x1 number. Why did we do that? Well, let's unwind this algebra a little bit. If we take this and we double it, and we go, and I'm going to move this down here, 2x1 equals x0 plus n, how am I doing this? 2 over x0. That's not right. No. That's that. The 1/2 goes away. Everything else stays the same. So this is very easy. We take x0, 4473, plus n over x0, which is here. And in the first division, we take x0 plus n over x0, which is this, and we add them together to get 2x1, which is this number here for the second division. Now, why is that easier? Well, if we look at it this way, we have x2 equals 1/2 of all this. So now if we move x2 down here, that equals x1 over 2 plus n over 2x1. Well, we have 2x1 here. In order to get 2x1 up here, we multiply by 2 over 2, and we end up with 2x1 over 4. And if we calculate 2x1 here, then it's easier to plug into this formula to get x2, which is what I did for the second division here. This is 2x1. We divide it by 2 and divide it by 2 again to get this number here. And then we take n over 2x1. There's n. And this is 2x1. We actually multiply by 10, so we had to multiply this by 10 to do the division correctly. So we divide by n over 2x1, and we get that answer here. And then we've calculated 2x1 over 4, which is this. We add the two together to get x2, which is that. And that's our final answer. That is the algebra behind how this method works. And that's all I have to explain about how to do square roots of an 8-digit number with an easier method than what's taught in classrooms.